Hello everyone, welcome to the OneClass channel. My name is Marlyn. I'm a second year chemical physics student at the University of Waterloo with a minor in math. Today I'm going to be working through some high school level and college level algebra problems. Be sure to check the links in the description if you're in need of any extra homework help or would like some one-on-one tutoring. Okay, so for our first question, we want to define what the zero exponent rule is. So the zero exponent rule simply states that any constant to the power of 0 is going to be equal to 1. So a can be any real number. And the reasoning for this is because you know a to the power of n, where n is also a real number, over a to the power of n is going to be 1. And because of the rule a to the power of b over a to the power of c is equal to a to the power of b minus c, we're just going to apply that here, and we get a to the power of n minus n, and n minus n is going to give us 0. And that's it for this question. Okay, for our next question, we are going to be solving for k. So in part A, we have e to the power of 2k is equal to 5. We are going to take the logarithm to the base of e on both sides. We know that because of the property log a is equal to 1, and log bc to the power of d is equal to d log bc. We will have log e to the power of 2k is going to give us 2k log e. This is going to become 1. So that's just going to be 2k. And we have said that that is going to be equal to log e5. We also need to note that we have a shorthand notation for this. So log to the base of e of any number is the same thing as ln of a. This is going to be equal to ln 5. And then next up, we just want to isolate for k. So we have 2k is equal to ln 5. Divide out the 2 on both sides. And then we get k is equal to ln, ln 5 all over 2. And that is going to be our final answer for that one. Part B. We have 2e to the power of 5k is equal to 8. But for this one, we first want to divide out the 2 on both sides. So e to the power of 5k is going to be equal to 4. Next up, we do the same exact thing that we did last time. So log e to the 5k is equal to log e4. This will give us 5k log e is equal to log e4. This is going to give us 1. So 5k is going to be equal to ln 4. And then you simply divide out 5. So k is equal to ln 4 all over 5. We can rewrite this as ln 2 squared over 5. And this will give us 2 ln 5. Sorry, 2 ln 2 over 5. And so this I simply got from the rule log e to the power of c is equal to c log e a. And we know that log e is just going to be ln a. And that's it for this one. For our last part of this question, we have 3 exponent k over 9 is equal to a. Just be careful with this so we don't get confused. So we have k over 9 is equal to a. Let's rewrite that as 3 e to the power of k over 9 is going to be equal to a. Divide out the 3 on both sides as we did in part B. So e to the power of k over 9 is equal to a over 3. Next up, we want to take the logarithm to the base of e on both sides. Okay, and then we're going to use the property to just bring that right over here. And then we also need to remember, just write down all the properties I'm using. So log a b to the power of c is equal to c log a b. Log a m over n is equal to log a m minus log a n. And lastly, log a is equal to 1. These are the main ones that we're going to be using. Sorry, we have one additional one. I'm just going to place it here. Log a is equal to ln of a. Log a m over n is equal to log a m minus log a n. And lastly, log base k of a is equal to 1. So next up, we are going to rewrite this, and note that this is going to be equal to 1. So k over 9 is going to be equal to log e a minus log e 3. So k over 9 is equal to ln a minus ln 3. And this will give us k is equal to 9 into ln a minus ln 3. And that's it for this question. Okay, so next up, we want to find which of the inequalities matches the graph. So a good way to just test your understanding of these inequalities is to actually plot all of them and see which one will give you the correct graph. So for option A, we have x is less than or equal to 5. So there are 3 parts of this inequality. We have the number, we have whether it's equal to, and lastly we have whether it's less than or greater than. So in this case, let's start with x is equal to 5. And so when you plot that, we have something like this. At the point 5, you'll have a line. Okay, so this is the line x is equal to 5. But then the inequality is x is less than or equal to 5. So it's both of them, which means for less than, we'll have all points before this line that we've sketched out, and including the line. So obviously, this will match what is in the question, and A will be correct. But just to continue on our understanding of these inequalities, let's plot the rest. Next up, we have x is greater than or equal to 5. So we start with x is equal to 5. And then we go to x is equal to 5 again. Get the line. If you want to just mark it, we have y, x. So we have the line x is equal to 5. And then the inequality is going to be x is greater than or equal to 5, which means we want all points beyond the line x is equal to 5 and including the line itself. So that will look like that. So it's almost the opposite of part A. Next up, we'll have y is less than or equal to 5. So again, we start with y is equal to 5. So we go here. Okay, and then we have y is less than or equal to. So I want all points including this line and below it. So on the y-axis, that is 5 and below. So 5, 4, 3, 2, all the way until negative infinity. And that will look like this on the graph. Lastly, we have y is greater than or equal to 5. Again, start with y is equal to 5. So if we define that as that point. And now in this case, we want y is greater than. So 6, 7, 8, all the way to infinity, including the line itself. And so that is all points above the line. And so just as an extra example, if the inequality doesn't include the equal sign, so take y is less than 3, then again, you start with y is equal to 3, but you make the note that in your inequality, y is not equal to 3. And so what that means is that when you draw it, find 3, draw the line, and then instead this time, because of the fact that y is not equal to 3, you're going to have a broken line, and that'll just signify that we are including all points not including the line. And so since y is less than 3, we want 2, 1 all the way until negative infinity. So it would look like that. And then the broken line just means not including the line 3 itself. And that's it for this question. So the answer is the first option, which is that. Okay, next up, we want to express as a single logarithm and if possible simplify. So let's first write down the logarithmic properties we can see we will need. And so we'll be using log a of b to the power of c is equal to c log a b. And we're going to be using it in this direction. And additionally, log the base of a of b minus log to the base of a of c is simply log to the base of a b over c. And we are going to be using that one in that direction. And additionally, we'll be using the rule that x to the power of a over x to the power of b is equal to x to the power of a minus b. So now, once we begin, we have log to the base of a, x to the power of 8, minus 2 log to the base of b, root x, right? And so in order to use this rule, we see that we have to have the same base and then a number. So we can't have a constant here in front of it. So to get it into that form, we're actually going to use the first rule, this one. We're going to be using it in this direction in order to bring this power 2 over here. And so we get log to the base of b of x to the power of 8 minus log to the base of b of root x squared. And we know that root x is x to the power of 1 over 2. So root x squared is x 1 over 2 squared. 2 times 1 over 2 is just 1. So it's just going to give us x. So let's just rewrite that as log to the base of b, x to the power of 8, minus log to the base of bx. Okay? And then next up, we're going to be using this rule. We see that they have the same base, so it just means that we're going to do x to the power of 8 over x. So this will become log to the base of b, x to the power of 8 over x. And we know that x to the power of 8 over x is the same thing as x to the power of 8 minus 1, based off of this rule. And that would be log to the base of b of x to the power of 7. So in the scenario where b was if b equals x, then we use a combination of this first one with the fact that log x of x will be 1, and we would get the answer log x, x to the power of 7 is simply 7. But this is in the scenario b is x. We have not been told that, so this is going to be our final answer. Okay, next up, we would like to solve for w in this. So we have 5w plus 9z is 2z plus 3w. Solve for w means we want w on one side of the equation and everything else on the other side of the equation, so we can say w is equal to something that doesn't include any w's. So first up, we can start by subtracting 3 from both sides. 3w, sorry. These two will cancel, and so we get 5w minus 3w plus 9z is going to be equal to 2z. This is going to give us 2w plus 9z is equal to 2z. Next up, we want to subtract 9z from both sides so we can have w on its own. These two will cancel. So 2w is equal to 2z minus 9z, and that is going to give us negative 7z. And then lastly, we divide out the 2 on both sides in order to enable them to cancel. So w is equal to negative 7 over 2z. Just in case you don't understand how and why I'm choosing my values, I chose negative 3w here because it would cancel the positive 3w. Here, I chose negative 9z on this side in order to cancel the 9z and bring it over to this other side. And then lastly, since w is multiplied by 2 here, if I divide it by 2, it'll cancel out, and I have to divide the other side by 2 as well. And this will be our final answer. Okay, next up we have a polynomial with integer coefficients and a leading coefficient of 1 whose zeros in degree are given. So we have x is equal to -5 with a multiplicity of 1, and x is equal to -1 with a multiplicity of 2. So if we write this, we get x plus 5, and since the multiplicity is 1, it's to the power of 1. And we get x plus 1, multiplicity is 2, so instead it's going to be to the power of 2. And so now we just combine those two, and you get x plus 5, and x plus 1 squared is equal to f of x. F of x is equal to 0. At the zeros, that makes sense. -5 plus 5 will give you 0, making all of this 0. -1 plus 1 will give you 0, making all of it 0. And so, moving on, we just want to expand that out. So first we can start with x plus 1 squared. We know that x plus a squared is going to give us x squared plus 2ax plus a squared. So just replace a with 1, and we get x plus 5 into x squared plus 2x plus 1 is equal to f of x. And then now we just multiply x by all of these using FOIL, plus 5 by all of these using FOIL. Next up, we get x cubed plus 2x squared plus x plus 5x squared plus 10x plus 5 is equal to f of x. And then we just bring our like symbols together. So we have x cubed, 2x squared plus 5x squared, that's going to give us 7x squared. 10x plus x is going to give us 11x plus 5 is equal to f of x. And that is going to be our final answer. Okay, next up we have a similar question. Okay, so we want to write a polynomial of least degree with integral coefficients. So least degree means multiplicity of 1 across the board. That has given zeros of -3, -1/3, and 5. Let's just write down the zeros. Okay, and then we can just rewrite all of them. So it'll be x plus 3 to the power of 1. We're going to have x plus 1/3 to the power of 1, and x minus 5 to the power of 1, and that's going to be our f of x. But we need to note the fact that they asked for integral coefficients. This does not have an integral coefficient because we don't have an integer as the second number. This does have an integer and this does have an integer, but this one it isn't the case. So we can solve this by noting the fact that x is equal to -1/3 is the same thing as 3x is equal to -1, which will become 3x plus 1. So basically multiply the entire thing by 3. So let's rewrite that. And I get x plus 3, 3x plus 1, x minus 5 is equal to our f of x. And then we can start with these two. So just use FOIL. And so we get x plus 3 into 3x squared minus 15x plus x minus 5 is equal to 0. So 3x squared minus 15x plus, sorry, back 3x squared minus 15x plus x minus 5. Let's simplify that. Okay. And then again, we want to FOIL. So x by all of them, followed by 3 by all of them. So that will become 3x cubed minus 14x squared minus 5x plus 9x squared minus 14 into 3, 32, minus 15. And this is going to be our f of x. And then we just collect like terms, which will give us 3x cubed. Negative 14x squared plus 9x is going to give us negative 5x, I believe. Negative 5x squared. Negative 5x minus 42x is going to give us negative 47x minus 15 is going to be our f of x. And this is going to be the final answer. Okay, next up we want to figure out how to find the vertex of a quadratic function. And so in order to find the vertex, we have to bring it into vertex form. Vertex form is y is equal to a x minus h squared plus k. So now one has to wonder how to get it into that vertex form. And so given y is equal to ax squared plus bx plus c, first off, we're going to bring the constant value over. So ax squared plus bx. Next up, we want to isolate x values. Next up, we want to remove any common factors. So let's say in this case we don't have any. And then next up, we will complete the square to get it into the form y is equal to some number. Let's call it c. That would be our common factor. And then we have x plus a, let's not use a, x plus d squared. And then obviously, because we've completed the square, there's going to be an extra variable that we're going to have to take out. So let's call it e. Then you're going to want to bring the e over to get y minus c minus d is equal to, sorry, I used the same variable twice. Let's use f instead. F into x plus d squared. And then you're going to bring everything back on over. And we have y is equal to x plus d squared plus c plus e. And then now you just figure out h and k from the general form and plug in what your vertex is going to be. So let's do a couple examples of that. Let's say we're given the equation y is equal to 6x squared minus 12x minus 10. Sorry, plus 12x minus 10. So first off, we're going to bring the number on. So y plus 10 is equal to 6x squared plus 12x. Next, we want to remove any common factors. So y plus 10 is equal to 6 into x squared plus 2x. And next up, we want to complete the square. So for this part, let's just do it on the side quite quickly. We know that x plus 1 squared is going to give us x squared plus 2x plus 1. This means that x squared plus 2x is going to be x plus 1 squared minus 1. So we want to take away that extra one that we have left over. So when we go back to what we were doing, we get y plus 10 is equal to 6 into x plus 1 squared minus 1. Next up, we will want to bring out what this constant is equal to 6 into x plus 1 squared minus 6. We simply just multiply it by the constant. And then bring the 6 over. We get y plus 16 is equal to 6 into x plus 1 squared. And then just take that back. So y is equal to 6 into x plus 1 squared minus 16. Next up, just refer back to the general formula. We have h is equal to -1 in this case. And additionally, k is equal to -16. And so our vertex will be located at the point -1, -16. Okay, let's do a second example. Let's say we are given one that is a bit less perfect, and that would be the equation y is equal to 9x squared plus 27x plus 18. So again, isolate those x terms. Y minus 18 is equal to 9x squared plus 27x. Next up, we want to remove any common factors. So we're going to divide out the 9 and we'll get x squared plus 3x. Okay, and then now we want to complete the square. We're going to do it on the side in a different color. And so we know x squared, if we have, so we want to figure out what square will give us that 3x. And it's not as direct as the 2x. So we know that x plus a squared is going to give us x squared plus 2ax plus a squared. And so we want 2a to be equal to 3, which means that a squared, and this means that a is equal to 3 over 2. And this would mean that a squared is equal to 9 over 4. So all in all, this means that x squared plus 3x is equal to x plus 3 over 2 squared minus 9 over 4. We want to take away that extra factor that's here. So now, let's just plug all of that back in. And we get y is equal, y minus 18 is equal to 9 into x plus 3 over 2 squared minus 9 over 4. Let's put that all in brackets. And then you want to take out this factor so that it can be on its own. So we get 9 into x plus 3 over 2 squared minus 81 over 4 is equal to y minus 18. Next up, just bring that over, and you get y minus 18 plus 81 over 4. And that can also be expressed as y plus 2.25 is equal to 9 into x plus 3 over 2 squared. Now let's take it back into the general form. We get y is equal to 9 into x plus 3 over 2 squared minus 2.25. Refer back to the general form. And we have h is equal to -3 over 2, and k is equal to -2.25, which means that our vertex is going to be at -3 over 2 and -9 over 4 is what this corresponds to. And this will be our final answer. Okay, for our next question, we want to factor x cubed plus 8. We're going to use the sum of cubes, because we can just note that x cubed plus 8 is the same thing as x cubed plus 2 cubed. Now the sum of cubes will be a plus b into a squared minus ab plus b squared. Just plug in those values and we get x plus 2 into x squared minus 2x plus 4. And this is going to be our final answer. Next up, we're going to use the binomial formula to expand this out. So we want x plus 1 cubed, and we just need to note down what the binomial formula is. It just states that x plus y to the power of n will be the sum from k is equal to 0 until n of n, choose k, x to the power of n minus k, y to the power of k. So now let's plug in what we actually have. X plus 1 cubed will be the sum from k is equal to 0 to 3 of 3, choose k, x to the power of 3 minus k, 1 to the power of k. If we actually write that out, let's start with k is equal to 0. So 3 choose 0, x to the power of 3 minus 0, 1 to the power of 0, plus, next up, k is equal to 1, 3 choose 1, x to the power of 3 minus 1, 1 to the power of 1, next up, k is equal to 2, 3 choose 2, x to the power of 3 minus 2, 1 to the power of 2. Last, we have k is equal to 3, so 3 choose 3, x to the power of 3 minus 3, 1 to the power of 3. 3 choose 0 is going to give us 1, 3 choose 1 is 3, 3 choose 2 is 3, and 3 choose 3 is going to be 1. So the final answer will look like 1x cubed, 1 to the power of 0 is 1, plus 3x squared plus 3x plus 1. And then we simplify that, x cubed plus 3x squared plus 3x plus 1. Additionally, you could just use Pascal's triangle to figure out what the coefficients should look like, and they're correct. 1, 3, 3, 1. For this one, we're just going to use product sum. And so you want product sum, you want the product to be negative 40 and the sum to be 6. The two numbers that will give us that are going to be usually you can just think of them quickly. If you can't, just use the quadratic formula and you should get 10 and 4. And so you're going to get x plus 10 and x minus 4 is equal to 0. And those are going to be your final answers. Solve for h. So we're going to divide out the L and the W. We are to isolate h, and we get h is equal to v over LW. And that's our final answer. Okay. And And those are all of the questions that I have for you today. I hope you enjoyed today's Q&A. If you'd like to be notified of when we do post, be sure to hit the subscribe button and the bell right next to it. If you'd like to be able to post your own question, check out the links in the description. This has been Marlyn from OneClass, and I hope to see you next time.